Hi there, Rodriguez here. We are moving on to other quadrilaterals. So you've done a lot of stuff with parallelograms, which was that first column of your cheat sheet there. So now we're moving on to the other two columns, and we'll be filling in some information about that. We are focusing in on the properties of trapezoids and kites. All right, so let's go ahead and get started. So some really important definitions that we have is first of what a trapezoid is. I'm sure that you can look at it visually, but let's look at it specifically. A trapezoid is a quadrilateral that has one pair of parallel sides. So parallelograms have two pairs, trapezoids only have one pair. Those guys are called our bases. So we have sometimes it's on the top and the bottom. We call it base one and base two. Sometimes if it's rotated 90 degrees, then they're going to be side to side, left to right. So just kind of keep that in mind. Those non-parallel sides are called legs. The two angles that share a base of a trapezoid are called base angles. So let's take a look at a trapezoid in general. So what I was talking about here, marked by these arrows, these are the parallel lines. So all of these angles hitting the base, those are our base angles. Kind of like when we talked about isosceles triangles, the two base angles were the congruent ones. These are kind of the same idea. The two sides that are not parallel, those are our legs. Now we can get kind of more specific with our trapezoids. We can call it the isosceles trapezoids, and that's going to happen when two of the legs are congruent. Okay, so we can work with triangles here trapezoids here on the left with non-congruent legs, or we can work with ones that have congruent legs. So let's take a look at some properties here. Now this is specific to isosceles trapezoids, not to all trapezoids. So if a quadrilateral is an isosceles trapezoid, then a couple things happen. First, each pair of base angles are congruent. So the ones that are touching the top parallel part, those guys are congruent, and the ones that are touching the bottom parallel part, those guys are congruent, but not necessarily to each other. Okay, if that was the case, then we met it with some parallelograms. Okay, so looking at the diagram to kind of get a bit better visual, P and P on the bottom there, they're congruent to each other, and R and A at the top there, they are congruent to each other. The other thing, kind of like rectangles, but obviously it's not a rectangle, the diagonals are going to be congruent to each other. So if I were to connect R to P, this one B to D and C to A, they are congruent to each other. Now, they're not necessarily being bisected. In fact, they are not being bisected. So what I mean by that is that from B to this point here in the middle and C to this point, those guys might be the same, but from here to here and from that point to D, that is not necessarily the same. Okay, so please keep that in mind. You cannot assume that those guys are going to be equal. The entire length of BD is congruent to the entire length of AC. Okay. All right, one more important property of trapezoids. It talks about the guy in the middle there, the mid-segment. We've seen mid-segments in triangles before. It's going to be parallel to the base, while mid-segments for triangles are parallel to that third side. This is going to be parallel to both of these bases, especially because we have that pair. So we're not going to draw one that goes down the middle right here. Okay, so just kind of keep that in mind. And then the second property here is that the length of the mid-segments is the average of the lengths of the bases. So in a triangle, all we did was cut that mid-segment, the value of that third side, in half. Well, in this one, since we don't come to a point, we have to take that into consideration here. So what we're going to do is we're going to add this piece RA with this piece TP here and cut that in half. So we're finding the average of the two bases. So it's directly in the middle of the two things. Okay, so let's look at an example here. We're going to find the measures. Now we see here it's an isosceles trapezoid given by the fact that these two legs here are congruent. So we're going to go through and find some of those measures. So the first thing I know is because it's isosceles, the base angles are going to have to be congruent. So angle F is 65 degrees. And then since we have ourselves the two parallel sides, we technically have the consecutive interior. So what that means is when I add C to D and then when I add E to F, both of those things are going to add up to 180 degrees. Well, I already know what C and F are, so I can substitute those values in and solve. So those other two top angles, angle D and angle E, those are 115 degrees. Okay, so again, that's because we have ourselves a set of parallel lines, so we technically have the consecutive interior or same side interior. Okay. Now let's take a look at the next one here. We want to know the measure of the base angles given the triangle of 1 of 20. So the first thing I see here is that we're talking about 1 of 20 isosceles triangles that exist within, it looks like an entire circle here. So we're really looking at this isosceles triangle or trapezoid right here. We know that is because if these are going to be isosceles triangles, then these guys are going to have the same lengths as well, all the way around, okay? So the first thing I want to do is really find the measure of that angle 1 there, and since it's a circle, it's going to add up to 360 degrees. You'll get more detail with circles the next unit. So we're going to take 360 and divide it by how many triangles we have, so we're going to divide by 20, and we get 18. So the measure of angle 1 is 18. Well, from there now, I can go through and find x. Since this is an isosceles triangle, that means the length from here to here are both going to be the same. So that means these bottom two angles are also going to be congruent. Excuse me. So x plus x is equal to 18. So I'm going to go ahead and solve for x, subtract the 18 and divide by 2. So that means the x value is 81. Now y is not going to be 81 because remember y is going to be the same measure here and here. So I know that x plus y is going to add up to 180. Okay, or in other words, 81 plus y equals 180. So subtract 81 from both sides and I get the y is equal to 99. Okay? Alrighty. Last but not least, we're going to work with the mid segments. So I'm telling you this is a mid-segment, and this is for all trapezoids, not just for the isosceles ones. So these measures don't necessarily, MN and LP aren't necessarily congruent. So remember when we talked about this, it's going to be the average. So that means I'm going to add both LM to PN together, and then I'm going to cut that in half. And that's going to be equal to the length of QR. So that's what I'm setting up first in terms of letters. Now let's go ahead and substitute all of our expressions in. So QR is x plus 2. LM is 4x minus 10, and PN is 8. And now from here, we're going to use algebra. So we're going to combine our like terms. And now you can either distribute through with the 1/2, or you can multiply both sides by 2 to get rid of the 1/2. I went ahead, since everything was even inside the parentheses, I distributed through with the 1/2, and I get 2x minus 1. And then from here, we're solving, going to move the x to the right and the 1 to the left. So the x value is equal to 3. Okay, so again, we're finding the average of one, not just taking half of the biggest side, okay? Alrighty, like all my transitions there. All right, moving on, we're gonna go ahead and look at kites now. Kites are a little bit different. A kite is a quadrilateral with two pairs of consecutive sides, that means one right after the other, that are congruent. We have no opposite sides being congruent. So these guys right next to each other, they're congruent. And these guys next to each other are congruent, but you can see that when we look across from each other, that is not going to happen. So when we got two pairs of consecutive sides being congruent, that's when we have ourselves a kite. So some properties of kites, just like the rhombuses and the squares, we actually have diagonals here being perpendicular to each other. So I know that we've got a right angle formed when those two things are coming together. Okay. Now, there's a couple of interesting things that happen here. Since AB is congruent to AD, and I know that these guys are perpendicular, by the perpendicular converse, I know that BE is congruent to ED. Okay, I don't know if you remember that from way back when, but if we had a perpendicular bisector in which it was equidistant from a point, then said it backwards. If we have ourselves a perpendicular line and it's equidistant to a point, then we know it's going to bisect that line, BD. That's what the perpendicular bisector converse is. So this is important to note that BE is congruent to DE because it's going to lead to a lot of different things. Well, they share this side. We know that these were congruent because it's a kite, and if these last two things are congruent, that means these two triangles on the top and the bottom are congruent by side, side, side. But those aren't the only ones. We've got ourselves the triangles on the right, triangle BEC. This triangle here is going to be congruent to the triangle down here for the same exact reason. Also, taking a look at the big triangles that we have, splitting it right in half top to bottom. These triangles are going to be congruent to each other. And that's important to note because when you're going to start solving problems, I might give you the value here at EBC and something over here for EDC. Well, those two things are going to be equal to each other. So this is really important for you to understand, is that we've got ourselves 1, 2, and 3 pairs of triangles within there that are congruent to each other. And that's going to be very helpful when you start solving problems. All right, let's move on. So this is an example of what I was talking about. I'm going to start with finding the measure of angle 1. Since the diagonals are perpendicular, I know angle 1 is 90 degrees. And then I have a right triangle, so I can go ahead and find angle 2. So I'm going to do 180 minus 90 minus 52. So angle 2 is going to be 38 degrees. And then last but not least, I'm going to find angle 3. Well, this here is where knowing that those two triangles at the top left and right, so this triangle and this triangle are congruent to each other, this is where it's going to be really important. So angle 3 is going to also be 52 degrees. Again, that's mostly because we knew that the two triangles on the left and the right are congruent to each other. That's super important for you to recognize there. Okay? All right, we're going to fill in the rest of your flow chart there that you can use. So I'm going to go ahead and push through the trapezoid properties. If you want to put the diagrams in there, feel free to. You don't have to. It's just for you to do, just to have a visual of things. Our right trapezoids, they just have a right angle, but they have all the properties of trapezoids. And then we have all of our kites in there. We're not going to really see a lot with our right trapezoids and our right kites, but it's just kind of good to kind of recognize that they're going to have the same properties as the trapezoid and so on. Okay, so go ahead and hit the pause button and get this filled out in your flow chart, and in just a moment I will move on. Okay, hopefully you got that in because you are going to be allowed to use this on the test. All right, that was it. Okay, so go ahead and hit the stop button and go ahead and begin your practice.